Okay, in this video, I'm going to show you how to make three different types of graph in R and RStudio, including histograms, bar graphs, and also box plots. Before we do that, I'll just quickly note a couple of useful functions here. So if I want to start with a fresh console, I can just click this little broomstick here. It'll sweep away the content. So it just disappears, the console's clean. If I want to start with a new environment, all right, so currently I have a variable here called age, but I want to take it out, then I can clear it again by hitting this little broomstick right here. It'll ask me if I'm really sure, yes. Okay, and before you conduct this particular activity, make sure that your mass package is been selected and it's available, all right? Okay, so first thing we'll take a look at in the code here. I know it looks complicated, but once I explain it, I think it'll be pretty straightforward. This is not very difficult code to learn. The first line here on 23 is the basic code required to make a histogram. So the function name is hist, and then in brackets we identify where the data is coming from. So it's coming from our Cars 93 data frame, and we want the variable of price to be included in the histogram. So I'll hit Command Return here, and then we can see down here in plots, we've got our histogram of cars, of the price of the cars from 1993. Okay, so I know this looks a little ugly, right? So we've got 0 and then 5, and then jumps to 15 and 25, and we've also got, some unhelpful labels, right? The label of the x-axis is Cars 93 $price. This is our title. It's not very helpful. One thing you can do, I'll note right now, is that if you want to see what the graph actually looks like, right now it's just sort of crammed in the bottom right corner, but you hit zoom here, and then it pops up in a separate window, and now you can see what the whole graph looks like. Notice that the y-axis looks much better. It's more evenly spaced. Okay. All right. So that's your basic default graph. But one of the nice things about R is that we actually have a lot of control over every single element in the histogram graph and the other graphs as well. So here, starting on line 24, what we have are our basic code to create a histogram, right? So we have the hist function, right? We're going to draw the variable of price from the data frame Cars 93, and then comma, and then all these are called arguments that follow the comma, each one separated by a comma, and each one dictates a certain aspect of the graph. So xlim is an argument that defines the limits or the values that are going to be included on the x-axis. So in this case, xlim is going to have values starting at 0 and ending or a maximum value of 70. xlab is a argument that is going to define the label that is associated with the x-axis. And so the label has to be in quotation marks. And so we've going to call the x-axis price in thousands of dollars, right? And then comma. And then ylab is similar to xlab, but for the y-axis, we want that one called proportion. We want to define the title of our graph, right? And so that's with the argument main, right? And again, quotation marks, these are the prices of 93 cars sold in the USA during 1993. And then another comma. And then we're going to make the bars red in color. So the argument COL stands for color, and we're setting it to red. Notice that red is also in quotation marks. And this last one here is what makes our graph a probability histogram as opposed to a frequency histogram, which is why our Y label is proportion and not frequency. So if you just want a regular histogram, you don't want a probability histogram, then just leave this last argument out, okay? Notice that there's no quotation marks around true. All right, so let's execute this code. Command return. All right, and you can see the graph. Let me just zoom it up here. Okay, and we can see it better. All right, so we have proportion along the y-axis. There's our title, right? Prices of 93 cars sold. Price in thousands of dollars. Our bars, our bins are now red, as they typically are for histograms. Note that we know it's a histogram because the bars are flush against each other. There's no spaces in between the bars, right? That's what makes it a histogram. All right. So next we're going to learn how to make a bar graph. Unfortunately, the first thing that you have to do before you can make a bar graph is to create a table. And the table is going to contain the values that are going to be plotted on the bar graph. So we're going to use the table function, right? And then we're just going to, again, use our Cars93 data frame. This time we want type, right? Price, of course, is a quantitative variable so that we can create a histogram with quantitative variables. Bar graphs we use for categorical variables, right? And so type of car is a categorical variable. Right, so first thing we're going to do is we're going to create the table here, command return. And now you can see our table. We've got different sizes, compact, large, mid-size, small, sporty, van, and we have their frequency, right? The frequency in each of those categories. And now what we're going to do is we're going to create a bar plot, right? And then we're going to use the table as the source of data for the data for our bar plot. So table, Cars93 $type. Don't forget the double brackets at the end of this, right? So we've got one bracket, right? That's the inside bracket. Sorry, that's the outside bracket. That there is the inside bracket. Okay, so let's execute this code. And there we go. So I'll zoom it so we can see better what it looks like. All right, so notice that in the small corner, we don't even get to see all of the different types of vehicles. But once we zoom in, then we can see that, in fact, each one does have a label. Okay. All right, so again, we can add arguments in order to increase the complexity or the appeal of the graph. So again, we got Y lim here, Y label, X label, main. Now we have a new one here. It's called access.lty equals solid. And we also have this one here, another argument called space. This one here determines the gap that occurs in between the bars. So you can control whether those are bigger gaps or smaller gaps. And then here, I'm going to set color equal to gray 1. All right, and then let's see what the graph looks like here. All right, so again, I'm going to hit zoom here so that we can see it better. So there's our title, frequency of 6 different car types sold in 1993. Right, so we have frequency along the y-axis. We have our different vehicle types. Car type is now our x-axis label. And notice that even though I specified the color to be gray 1, we got black bars. So why is that? Well, there's actually 100 different shades of gray that you can use. Gray 1 is black. Gray 100 is white. And everything in between are different shades of gray. So if you want 50% gray, then gray 50. And you can see that's what it looks like. If you want it to be a little bit lighter, then it has to be closer to 100. So for instance, gray 80 is actually 20% gray. Okay, also notice that in your plots tab here, you can navigate to previous graphs that you have made, right? So they're not lost. Once you create a new one, the other ones aren't lost. Okay, so next we'll take a look at box plots. So here the function is called box plot. We're going to use cars 93 again as the source of our data. And now we have two variables. Remember that a box plot is used to illustrate the relationship between two variables. In this case, horsepower, which is a quantitative variable, and cylinders, which is also quantitative, but you can also think about this as categorical, right? It's kind of stuck in between a category and a quantitative variable. So this little squiggly mark here means dependent on. So what we want to do is we want to plot the horsepower variable dependent on the number of cylinders. So as such, horsepower is the dependent variable because it's dependent on cylinders, and cylinders is our independent variable. So what this means is that cylinders, being the independent variable, will be on the x-axis. Horsepower, being the dependent variable, will be on the y-axis. All right, and so that's the basic code. I think you get the idea now, but I'm going to skip to the one with the fancier arguments that have been added. Notice this time I'm using colors equals orange. You can pretty much any common color that you can think of, if you put it in quotation marks, it'll be used here. So let's take a look. Okay, and there is our box plot. So we can see that cylinders here, so 3-cylinder cars, 4-cylinder cars, up to 8-cylinder cars. And then we have a rotary type of car. There's only one car that's a rotary car. Rotary cars, incidentally, don't have cylinders. They are basically a mechanical turbo is basically what a rotary is. Okay, so we can see the medians, the first quartile, third quartile, the minimum value, the maximum value, and also you can see that we have outliers on some of these. And we can also see that in general, as the number of cylinders increases, that the horsepower also increases. All right, so one thing I also wanted to note is that this code that are associated with making these graphs is one reason why we like to use the scripts instead of just directly entering code into the console. Once it's in the script, then we can execute it as many times as we want. We can edit the script and then execute it again if we want it slightly different. And if we come back next week and we want to create the graph again, then we can just execute the code, because remember that all the code in the scripts is being saved. That's not true. Once something is executed here in the console, you have to retype all the code. This is quite a bit of a code to be typing, so you probably want to use the scripts. Also, if you are copying and pasting code into the scripts, one thing to watch out for is these little quotation marks. So you'll notice that the quotation mark that you get when you copy and paste something in from Word, for example, is not necessarily the same as what it looks like in RStudio or in R. And as such, it won't work. So R is not recognizing this as being a quotation mark. And that's why you see this little X here, right? It's telling you that there's something wrong in your line of code. And also giving you an idea, right? It's an unexpected token, and the with the quotation marks, the 66 and 99s. And that's telling you that it doesn't recognize that symbol. And so to fix this, what you have to do is replace all of the quotation marks, just retype them, delete them and retype them, and so on and so forth. Okay, you also notice that the code is so long that after a comma, I can hit the return and then continue the line of code on the next level or on the next line, right? And that's perfectly acceptable. It's no problem. You don't have to do that, right? You can actually keep it all on a single line, and it'll execute exactly the same way. All right, so that concludes this tutorial. In the next one, I'm going to show you how to make the same 3 graphs, but using a more sophisticated package that's available in R.